Beautiful. Vertical motion word problem. So we're going to look at a formula today, which is often written like this. Height is h.
Negative 16t squared minus something.
Equals negative 16t squared plus something.
And then there's different ways of writing this. I'm going to write S.
Right, yeah, we didn't have, what's that little O beneath the T?
Okay, so in this equation, this is the height of an object after t seconds. And because of that, it's often not written just h. It's often written as h of t instead. You guys have seen notation like that before because we've done something like y equals x squared plus x plus 5, but then we've also done f of x instead of y. It's just a different type of notation, just a different way of writing it. I think technically this one is better because it reminds us that it's not like a certain height. It's the height after t seconds. So h of t is how I would read that, is the height of your object after a certain amount of time has passed. So we can't really know the height unless we know the time, or vice versa. They go together. They're a function. So the height and the time are connected. And what this equation is saying is just a basic principle of physics, right? The height of any object, whether it's thrown, dropped, kicked, whatever, as it's moving through the air, the height of that object is a function of the time that it's been in the air. So if I drop an object from up here, its height will go down as more seconds pass, right? Its height starts up here, and then as a second passes, the object's height decreases, right? If I throw an object, right, like from the ground and kind of throw it up, the height at first goes up, and then it comes back down. And it doesn't matter if I throw it sideways or if I just throw it up. We're not talking about the path of the object here. We're talking about the vertical motion. So what I'm saying is if I throw this marker straight up, after 1 second, right, it might be 1 foot above my hand. After 2 seconds, it might be 4 feet above my hand. Right? After 3 seconds, maybe it's back down. Right? Maybe it's back down to 2 feet above my hand. After 4 seconds, maybe it's back down to 1 foot above my hand. And then maybe after 5 seconds, it's back in my hand. But that relationship is parabolic. It's a quadratic relationship. Okay? And it's a little bit tricky to understand that. And that's, people often get this confused with the path of an object is also a parabola. If I throw or drop an object, its path will form a parabola. And that's related to this, but it's not the exact same thing that we're saying. This equation applies for an object that's dropped straight down or thrown straight up. In which case, the path is not really a parabola. It's a line, right? Because it would go straight. But the time and height are still in a quadratic relationship. So any object that is thrown, kicked, dropped, tossed, lobbed, whatever, is going to have a function that can represent its height as a function of the time that it's been moved. And that h, the h of t, is the height of the object, right? So, for example, a really simple example would be if I started with an object on the ground, after 0 seconds, the height is going to be 0, right? So you can kind of picture that parabola. After 0 seconds, the height is going to be 0. And then after some amount of seconds, if I throw it up, what's going to happen eventually? It's going to fall back down. And so we can think of that as those x-intercepts of our parabola, right? No matter what, if I have an object, if it starts on the ground, after 0 seconds, its height is 0. And after some amount of time, it's going to be back on the ground. At some point, it will reach a maximum height, right? And that's the what of our parabola, the maximum height, the vertex. Yeah. So all these things that we've learned about parabolas can now be applied to vertical motion. We can find the vertex, we can find the zeros or the roots, and that can tell us something about the motion of an object. Okay, so t, as I said, is the time. And h and t are typically the only variables. The other things are going to be assigned a value. -16 is basically the coefficient of gravity, right? The reason that objects go up and fall down in parabolas is because of gravity. Gravity is a force of acceleration that's pulling on an object, and this number is basically just telling us how much force gravity has on a given object. So this is related to gravity. With a -16, it doesn't change as long as we're on Earth. It could change if you went to another planet. This is related to the initial, and that's what that little 0 subscript stands for, initial velocity. Yeah, and it is the initial vertical velocity. We're only talking here about vertical velocity. So the initial vertical velocity or the initial velocity. And in order to solve these types of problems, you're typically going to know what that initial velocity was. Or you'll know the height and time, and then you can solve for vertical velocity. But we won't be doing that a lot. Mostly, the problem itself is going to say an object is kicked with an initial vertical velocity of 32 feet per second. And then s, which is sometimes written as h sub 0, is the initial height. So where did it start? Did the object start on the ground, or did it start from a cliff? And you can picture that parabola, right? If an object starts on a cliff and is falling down towards the ground, that just means the parabola might look something like this, right? Or maybe it's more like this. So here's your starting point, right? And then does the object go up from there? Does it go straight down from there? And the thing about these problems is there's often parts of that parabola that make no sense. So if we think about this axis being our height, right? The y-axis is now our h-axis, and this axis is our time. The negative time doesn't make any sense in the real world. But in our mathematical model, in our mathematical equation, you will get answers where time is 0. I mean, time is less than 0. Time is negative, but then if you think about how would that apply in the real world, it doesn't, right? So even though our parabola mathematically might look like this, in the real world it looks something like this. We wouldn't count the negative time parts of that parabola. So often you're going to get 2 answers, and you have to eliminate the negative answer because it doesn't make any sense to have a negative amount of time. So we're thinking about these objects, right, kind of being thrown, starting from different heights with different velocities, and they're going to form different shaped parabolas.
Wait, so we should always take the higher, like the bigger number. If we have two answers, we should always just take the bigger one for our
No.
time.
It's gonna depend. You're always gonna have to think about it a little bit.
If you get a negative, then you take the non-negative.
Yeah, if it asks you something like
1 and left 8.
then you would
just
have two
to-
answers probably. If it asks you something like after how long would the object land back on the ground? And your answers are t equals -4 or t equals 16. Well, we have to think back to the question. After how long? T is time. So after -4 seconds or after 16 seconds? The -4 is telling us sort of like since that object started up at this initial height.
If it was
-4 seconds ago it would have been on the ground if you like if you took a video of it and like played it in rewind and then somehow magically like got the object to keep going past where it actually started. But that doesn't really make sense. The -4, like time can't be -4 seconds. And so you choose the 16 seconds.
But yeah, like what if it's podcast, then it's 2 inches?
I'm trying to think. That typically doesn't happen. Yeah. And I don't want to necessarily go in right now to sort of why, but if you think about the way that these equations work,
Yeah.
you can kind of figure it out. All right. So let's take a look at an example. So I'm going to leave that formula. Actually, let's erase this and let's erase this. An object. Actually, let's make it a little bit. A rocket. A rocket is launched from a platform that is 16 So what is that telling us immediately right now?
the initial height. Yeah, 16.
So yeah, this 16 feet is that starting height. Right? And so we can immediately start, even before I finish this problem, we could immediately start to think about our equation as h equals -16 squared plus, and what I'm thinking right now is blank t. I'm not really thinking v0 because I'm pretty sure that they're going to give me v0, and then I'm thinking plus 16. Right? I'm kind of thinking like, where does each piece go in my equation? Does that make sense?
Mm-hmm.
A rocket is launched from a platform that is 16 feet in the air. Oops. With an initial vertical velocity of 32 feet per second. After how long will the rocket hit the ground? And so now actually we can plug in that this is 32 because that's our initial vertical velocity and something else. What else can we plug in? Yeah, what's the height that we're looking for?
0.
Well, that's the starting height, but the height that we're looking for is 0, right? When does it hit the ground? Then we immediately know, oh, it's asking me when will the height be 0. Right? This is the starting height. This is the height after a certain number of seconds. So now I have to solve this equation.
You can divide everything by 16.
Yeah, and I would actually divide everything by negative 16. Divide everything by negative 16. 0 divided by negative 16 is still 0. And then we've got t squared minus 2t minus 1. So I'm trying to think of factors of negative 1 that add up to negative 2.
Wait, it's negative squared? Negative 1? Oh, that looks like a 1. So, wouldn't it?
Can you think of anything?
Well, it can't be negative 1 and negative 1.
Right, because that would equal 1.
And if it was positive and negative, that would just be 0.
So there isn't anything. So what would we say?
The rocket doesn't exist.
It doesn't crash, it keeps going to the moon.
A rocket is launched up. We can't solve this by factoring.
We can solve it by
How would we solve it?
completing the square.
Completing the square.
Yeah, plus
I would do quadratic formula. Okay? So quadratic formula, instead of x equals, is now t equals. So t equals negative b, 2, plus or minus the square root of b squared, so 4, minus, except it's not minus, because minus 4ac, since the c is negative, that makes this plus 4 over 2a, which is just 2. So I just plugged everything into the quadratic formula.
and
Oh.
Negative b plus or minus the square root of b squared minus 4ac.
could we square root
with
the
2a.
4 and make it 2 plus 2?
We can't.
And 4.
We can't, but there is something that we can do. So t equals 2 plus or minus the square root of 8 over 2. Yeah, the square root of 8 is not 2, right? It's not 4. The square root of 8 we actually don't know. And so what I would do at this point for a problem like this is probably grab my calculator and I would type it in. So let's say the square root of 8, right? And first of all, I have 2 plus the square root of 8. The square root of 8 plus 2 equals 4.82842712 divided by 2. So one of my answers is 2.414213562.
Wait, do we have to write that many?
Yeah, write everything that shows on your calculator. The other option is, the other option is 2 minus the square root of 8, right? Which gives me, if I did it right, negative 0.414213562. Huh.
It's 2.41.
Yeah, time can't be negative. So we know that this is our answer. And at the end, it is totally fine with me if you round it, right? Most people don't count time with that many decimals. So if you want to just say something like, it
2.4.
will hit after 2.4 seconds.
Really?
That is fine.
Yeah, because it's not like those, like most of those are going to make much difference. Right. Yeah, you're not.
So you can round it, and I do think it's important to get in the habit, though, of writing out all your decimal places and using them. when you're doing math, it actually can make a huge difference. If you use 2.4 versus 2.41421356 as you're doing calculations, depending what you're going to do with those calculations, you can get really drastically different results. So it's a really good habit to just wait till the end, wait till you're done before you do any rounding. Now in this case, we were done as soon as we got it, so it doesn't really matter, but it is just a really good habit to get into. Round at the end. Only round when you're totally done. So we're solving quadratic equations. Now, as we realized here, right, there may be different options for how to solve them, right? Like we tried to factor it, but we couldn't, so we used the quadratic formula. If we could factor it, we probably would do it that way. But we just have to solve it however we can solve it. Is it possible that we would get no solution? Is that possible? Yeah, when would you get no solution? We get no solution when the discriminant is negative, right?
So what does that mean?
Yeah, but like in the real world, what does that mean?
Right.
Negative, like,
Yeah.
The
So
ball was never
I want to talk a little bit about this, but it doesn't. This is not like super important. You don't necessarily have to know this to solve these problems. But if you think about what would make the discriminant negative in a quadratic, it means that a times c times 4 is a positive number that is larger than b squared. So what would that mean? It would mean that both a and c would have to either be positive or negative. Because when we're multiplying 4 times a times c,
Wait, isn't it a negative sign?
right, there's a minus in front of it. So for b squared minus 4ac to come out negative, we can't have, if a is negative, this automatically becomes a positive, right? There's no way for it to be negative then. So if a and c are both negative, they cancel each other out. Since a is always negative in these problems,
you have to start underground.
yeah, the c would have to be a negative number.
Which doesn't really make sense.
No, it does.
Right.
If you start
Which-
underground.
I mean, yeah, you could think about it. You could think about like scenarios where that might happen, right? You could think about scenarios where that might happen, but then the other thing to think about is, okay, not only does that have to be a negative number, it also has to be true that the velocity squared, so whatever its velocity is squared, because that's over here, has to be smaller than 4 times a times c.
That's me going really slow
Right.
and underground.
Right, so in a way, we could say, when we have no solution, it's like something that's underground or underwater or whatever.
Oh, and it's going
And
slow to
it's-
get to the surface.
Right, and it's like going, the speed, right, that initial vertical velocity is really slow. So it would never really get up to the ground.
Yeah. We can't reach.
Technically that is, I mean,
Yeah. I
you
mean,
could
that works.
imagine scenarios where you could come up with an equation like that. Yeah, exactly, let's say I'm in a submarine. Let's say I'm in a submarine. If I call the top of the water 0 and I shoot a torpedo up, I could totally picture a torpedo that would never actually get to the surface of the water, right? It would get pulled back down. Now, if we're really talking about physics, like this equation doesn't really apply underwater because gravity doesn't really work the same way. Like
Well, if you were
things
like
would
underground,
change, right?
if you were like you digging a basement in your backyard,
Right.
and you
But
just
yeah.
throw a rock out of it. You dig
Sure.
it up, but then the rock doesn't go high enough and it hits the wall.
Right. So you're in your cellar, right? You're standing here in your cellar. You throw a ball, and it never actually gets to the top. That's totally possible. it's going to be sort of weird. Like, we're not going to see a lot of scenarios like that, right? But that's all it means. If we get no solution, it just means that object never crosses the ground. It never hits the ground. So maybe you're like down underground, you throw something, but you don't throw it hard enough to get up to the ground.
Well,
And if they ask you when will it hit the ground, well, it won't, because it never got that high, right?
Wait, but then what happens if like you throw something and it goes high enough, but then it just doesn't get onto the ground, and it just goes up, but then it
Mixes the ground.
Right. So it's all in how we define the problem, right? It's all about how we're defining our problem. Because if I were in an underground area throwing an object, I would probably call the ground of the area that I was in. So you could just redefine the problem to make it happen.
If you were underground and you threw something high enough that it went above the ground, but it didn't
Hit
get
the ground.
to the ground, so it went like this, and then it came back down, would the solution just be that top tiny half of that parabola?
Yeah, you could totally, you could imagine something like that happening. I want to do a more like, an example that's more like what you're going to see. Okay, this one's going to be, what? Okay. So, let's try this. A boulder is dropped from a helicopter 64 feet in the air. How long will it take to hit the ground? So a keyword here is dropped. Typically what dropped suggests is there is no initial vertical velocity. So in this case, our equation is going to be, we're looking for when it hits the ground, so 0. The negative 16t squared doesn't change. There's no initial vertical velocity. So I have 0t, which I'm not going to write, and then my starting height is 64. Oh, I can solve that. Again, I would divide everything in this equation by negative 16. So I would have 0 equals t squared minus 4. How do we solve that?
No, you do like find
Wait, you
Other
could
one
have
was
solved
not
it in
square
your
root.
one above. You could have done 8 times, or negative 8 times negative 8, which would have been negative 16.
We could have. Yeah. It's harder though. It's
Wait,
easier
so
to solve
you could
this.
just add 4 to both sides, and then square root of both sides,
You could.
and then t equals 2.
So 4 equals t squared. The square root of each side. T is positive or negative 2. The square root of 4 is positive or negative 2. And which one makes sense?
positive.
2. So it would take 2 seconds. There are many ways to solve this. We could have done difference of squares factoring. 0 equals t plus 2 times t minus 2. So t must be either negative 2 or positive. That doesn't totally show up on the video. You could have used the quadratic formula. It would end up being really simple, actually. Quadratic formula for this would be t equals negative b, 0, plus or minus the square root of 0, minus 4ac, plus 16, divided by 2. So t equals positive or negative square root of 16 divided by 2, which is positive or negative 4 divided by 2, which is positive or negative 2. Same answer,
But isn't it just
using the quadratic formula.
Isn't it just positive?
Yeah, it's positive because the negative time doesn't make sense, but we don't eliminate the negative answer until the very end. So however you want to solve this, it doesn't matter to me. I think this is probably the easiest way. Right? Add 4 to both sides, take the square root, and you're done. Alright, let's do one more example of a problem. Okay. Okay, so we punt a soccer ball. Boom. We're assuming that the person who punts it is hitting it like right on the ground. They drop it and they kick it perfectly on the ground. So what is 0? The starting height. There's no starting height now. We're starting the ball from the ground, kicking it up, and we're asking when will it hit the ground again. So again, when will it hit the ground? H is going to be 0. So 0 equals negative 16t squared. That never changes, at least not right now. What's our initial vertical velocity? 8 feet per second. So we've got 8t. And our starting height is 0. Okay, we can solve this. Divide everything by negative 8. Right? Why not negative 16? Well, 8 is not a factor of 16. Why not positive 8? Because we don't want the negative in front of the t squared.
Wait, couldn't
You
you also
could.
take out a t?
Okay, we'll get there. So divide everything by negative 8.
Then you just divide
0
by 8t, negative 8t.
equals
Would that not work?
0 equals 2t squared plus, minus t. Okay. Can we divide by t?
No, because there's a 1 and a 0.
What? We can divide by any number, right? So we can
There's
divide
no
by t
t.
because t is a number. Can we divide by any number?
Well, yeah.
What number can we not divide by?
0.
Is t 0?
No.
I have no idea if t is 0.
Wait.
I don't know what it is, so I can't divide by it
But
Can you take it out?
because
Like, can you put it in front
I don't know if it's 0.
But we do
So
know
I
that it's
can
not 0.
factor it out.
Yeah,
let's
add
add
t.
I can factor it out, right? I can do t times 2t minus 1. Those are my factors.
So then,
Wait, where did you get the
t
minus
equals
1?
0
So-
or 1 over 2.
Because I factored the t out for
And
q.
there's still
Right?
one
So
t
t times 2t gives me the 2t squared
minus 1 t.
minus t times 1 would give me the t. Yeah, so there's like an imaginary 1 here,
So Nate, would it be
So t equals either 0
0 or
or
1/2, right?
1 over 2. Yeah, 1/2.
So half a
Wait,
second.
how-
Which one is correct?
1/2.
Half a second. Wait, but 0 is not negative. It could land on the ground after 0 seconds.
That means it never left.
What is this telling us?
There was an initial vertical.
It was
velocity.
on the ground when time was 0. Isn't that what the problem said?
Yeah, because if it was on
That's
the
why
ground,
we get the 0. So because the ball started on the ground, after 0 seconds, it's on the ground. But that's not what they're asking for, right? They're asking the second time that it's on the ground, which is after half a second. Okay.